Today's lesson is going to be factoring a difference of perfect squares. The first thing we want to talk about is what are perfect squares. When a number, a variable, or expression is squared, the result is going to be a perfect square. For example, if we look at these numbers, 1 squared is 1, so 1 is a perfect square. 2 squared is 4, so 4 is a perfect square. 3 squared is 9, 9 is a perfect square. So each one of these, 16, 25, 36, those are all going to be perfect squares. So are all of these, 49, 64, 81, 100, 121, and 144. The list keeps going, as you know. Every number we square. 13 squared is 169, so 169 is a perfect square. You need to have these memorized pretty much up through at least 12 squared, and really through 15 squared, because you need to be able to recognize them quickly. Here we're going to square some variables. We're going to square x and we get x squared. That means x squared is a perfect square. X squared squared is x to the fourth, so x to the fourth is a perfect square. X cubed squared is x to the sixth, so that's a perfect square. X to the fourth is squared is x to the eighth. This would give us x to the 10th. And this would give us x to the 12th. And x to the 14th. What do you notice about the exponents of all of these perfect squares? X squared, x to the 4th, x to the 6th, x to the 8th. Their exponents are even. So if you see a variable with even exponents, it's going to be a perfect square. Is x to the 18th a perfect square? Yes. What squared gives us x to the 18th? Well, that would be x to the 9th squared. So that's a perfect square. AB squared is a squared b squared. So that would be a perfect square if you saw that. A cubed b to the 4th squared is a to the 6th, b to the 8th. Remember that distributes to both since there's no addition or subtraction. So this means this is a perfect square. You notice those exponents are still even, 6 and 8. X minus 1 times x minus 1 is x minus 1 squared, so that's a perfect square. 2x minus 5 times 2x minus 5 is 2x minus 5 squared. It could be an entire expression. This would be x plus y squared. As long as its exponent is even, that makes it a perfect square. So are these perfect squares? Can you think of a number that times itself gives you 400? That would be 20, so it's a perfect square. What times itself gives you 25? 5. So 25 is a perfect square. What about 4x squared? Well, that's 2x times 2x. So it's 20 times 20, 5 times 5. What about 25y? Is y's exponent even? So that's not a perfect square. What about x minus 1 to the 4th? That outside exponent is even, so that's a perfect square. That's x minus 1 squared. 16y to the 6th is 4y to the 3rd squared. It's a perfect square. What about 1/4? That would be 1/2 times 1/2, so it is a perfect square. What about 1/8? Is that 1/4 times 1/4? No, that would give us 1/16. So 1/8 is not a perfect square. 3x plus 1 squared, that is going to be a perfect square because its exponent is even. Okay, here we're going to go looking for a pattern. X plus 3 times x minus 3. If we FOIL that, we get x squared minus 3x plus 3x minus 9. If we simplify that, these two cancel out and we're left with x squared minus 9. When we FOIL this one, we get x squared minus 6x plus 6x minus 36. Our middle two cancel again and we're left with x squared minus 36. Let's look at it with some fractions. Here we go. We get x squared minus 1/3 x plus 1/3 x minus 1/9, because 1/3 times 1/3 is 1/9. You get x squared minus 1/9. The last one, we get 4x squared minus 14x plus 14x minus 49. So we have 4x squared minus 49. What do you notice about each of these? Do you see a pattern? They're all subtraction. Are any of those not perfect squares? They're all perfect squares and they're all subtraction. So these are called difference of perfect squares. When you look at what we were multiplying, x plus 3x minus 3, x plus 6 minus 6, there wasn't anything special about these, but it was the sum of two numbers times the difference of the same two numbers. When we do the sum of two numbers times the difference of those same two numbers, we end up with a difference of perfect squares. Let's use that pattern. This is the sum of two minus times the difference of the same two. So we're going to end up with the square of the first two minus the square of the second two. X squared minus 16. This one, we have x squared minus 25. The next one is going to be x squared minus, what is 1/7 squared? 1/49. You see, we're still ending up with a difference of perfect squares. 3x squared, oops, it's not 3x squared, it is 9x squared minus 1 squared is 1. So those are all difference of perfect squares. So let's look at these. If 4 times 4 equals 16, then 16 must equal 4 times 4. True statement. Okay. 12 times 12 equals 144. Then 144 must equal 12 times 12. X plus 1 times x plus 1 equals x plus 1 squared. Then we can write x plus 1 squared as x plus 1 times x plus 1. If x plus 2 times x minus 2 equals x squared minus 4, then we must be able to write x squared minus 4 as x plus 2, x minus 2. That's what we're looking for, this special pattern right here. If x plus y times x minus y equals x squared minus y squared, then x squared minus y squared is the same as x plus y times x minus y. This is the rule we use to factor when we have a difference of perfect squares. So let's factor these. Is this a difference of perfect squares? X squared minus 9. Yes. So that must be x plus 3 times x minus 3. If we multiply that, if we FOIL it, do we get this? Yes. So that's correct. X squared minus 144. They're both perfect squares, and it's subtraction, so we get x plus 12, x minus 12. Now I'm writing the addition sign first on all of these, but it doesn't matter. It could have been x minus 12 times x plus 12. This is still a difference of perfect squares, even though the 4 comes first. Since the 4 comes first, the 2 is going to come first in both of our expressions. 2 plus x, 2 minus x. On this last 2, we have 16x squared minus 9y squared. Those are both perfect squares. So we have 4x plus 3y and 4x minus 3y. On the last one, this is a perfect square, and so is this. So we have x plus 1 plus 6 and x plus 1 minus 6. Now on ones like these, you would want to simplify this. That would make it x plus 7 x minus 5. And that's how we factor a difference of perfect squares. This only works when you actually have perfect squares and they have to be being subtracted. Here are the ones for you to try. Have fun, and we'll look at this more in class.